right. Thank you so much for coming out this evening, especially on a Tuesday with everything that's going on. We appreciate you for being here tonight. We have some amazing speakers for you tonight to talk about cloud, Vertex, and Vertex Cloud AI. So I'm going to pass over to my team with go-to-market. We appreciate you being here, and we will get started.
Hey, thank you, everyone. I want to just give a shout out to GitHub for having Gemini now on GitHub. So that's awesome. Here's a QR code if you want to get in touch with anybody from the go-to-market team and you're working on anything with GCP. So I just wanted to make sure that we have a resource for you to reach out. So sometimes folks are like, oh, I don't know who to get in contact with. Well, if you scan that and fill that out, we could get in touch with you. Couple of things. Wanted to let you guys know about our Google Cloud for Startups program. We offer up to $350,000 for AI startups that are VC funded. So please feel free to apply. It's actually pretty easy to do online. And even if you just have a bootstrap idea, we encourage you to go ahead and apply online. So you get up to like a couple $1,000s to help kind of ideate and build your ideas on GCP. So please check that out. Try out Gemini. We have a couple other events actually also that we're hosting throughout the week. We're doing SF Takeover Week. We've had hackathons. We're participating today. And we also have some great events to really dive into BigQuery as well as with VCs. So Ask Me Anything. AMA stands for Ask Me Anything. So if you'd like to join us for some of these other events that are coming up this week, would love to see you. Today, I think I'm going to hand over, like she mentioned, we're going to be kind of diving a little bit more into the power of Gemini, and I'm going to hand it to our technical team to talk about a little bit more about that. If you have any questions, I'll be around. Feel free to reach out, and hope to see you at some other events this week at Google.
Thank you. Thank you. I'm going to turn it on over to Laxmi. She's going to talk about unlocking the power of Gemini API on Vertex AI.
Thank you, Aziza. Okay, so while we wait for these slides to load, how many of you here have worked on Gemini API, Vertex AI? Good, awesome. Good. So today's session is basically on how we are going to use Gemini API on the Vertex AI platform, which is Google's AI ML platform, right? So I'm Laxmi. I'm a field solution architect in generative AI with Google Cloud. So typically, when I ask developers about what aspects they feel are most important when they're trying to use LLM API, the answers that come in are usability, performance, of course, cost is another factor, followed by flexibility and customization. So in today's talk, what we'll do is we look at the Gemini APIs and see how it would all kind of fit in. We have a packed agenda today, and I'll try to cover as much as possible, right? So we get started with how to write a very simple API call with Gemini, followed by multimodal models, long context, context caching, PDF processing, control generation and grounding, prompting tools. We'll kind of end with takeaways, Q&A, and the other parts. So I'll be trying to run the notebooks for each of these, but based on time, if you're kind of running short, I might have to cut short, and then Q&A we can always do during the networking hours, because I have my colleagues from Google Cloud here who would also be happy to help you with the questions that you might have. Okay, so let's get started. Right, so if you look at Google's APIs for LLMs, the two latest ones are the Gemini 1.5 Flash and Pro. So both of them can handle multimodal data, which means that you can feed it text, audio, video with audio or just video, and PDF. And the output for both of the models are text. And if you are kind of looking to balance your performance with speed, I would say go with the Flash model. And if your performance is your key, go with the Pro model. And if you look at the Pro, it has got a context window of 2 million tokens. So we'll come a little deeper into that. But what it essentially means is the amount of input that can be passed on to the model in one API call. So if you have a Python SDK, how do you write an API call? So your first step is, of course, to do all the required imports, right? So the focus here is the first line, which is like import Vertex AI, because you're trying to run the whole thing on the Vertex AI platform. And the next step, of course, you kind of initialize it with the project ID, which is what you will have once you log into a GCP project. Again, you can choose the model, right? So you could choose Flash, you could choose the Pro, you could choose either a 1.5 version or a 1.0 version. And then what do you say? So what am I trying to do here? So I'm trying to ask the model to tell me about the countries, capital of the countries and the currency of the various countries. So how can I ask it that, right? So the first step, of course, is we have specified the model name, and then we kind of define a generative model of which, model name is the first parameter. And then you kind of give it a system instruction. So where you tell the model that, see, you are an expert in the global geography, you have a deep understanding of the countries, their capitals, currencies, and so on. So, and what you're supposed to do is answer these questions with a lot of confidence and accuracy. Then comes the model parameters. So that is what is specified in the generation config. And it's a combination of temperature, which is like, how random or say, creative you want the model to be. Then top P, which is basically, at the end of the day, what an LLM is trying to do is to predict the next word, right? So when it's at that point where it's in the kind of middle of a sentence, it has multiple options. So you could, and each of those options has a probability, right? So you could kind of specify that and then see which word it has to pick up. Then the candidate count. Basically, how many outputs you want the model to generate. And then the maximum output token, which is 8192 for both of these models as we speak. Then, of course, comes the safety settings. For any of these models, there are safety settings in terms of hate speech, sexually explicit content, dangerous content, harassment, and so on, for which you can kind of set the levels. So you could just say block just high and above or low. So these are basically the thresholds that you have. And again, mapping to the probability is what you'll get an output. Right, so we have set up everything. And now we come to the prompt. So what the user is asking us comes in the user input part, which is like, what is the capital of France? You put that into an array because that's a format in which Gemini takes it. And then what you could also do is take a look at how many tokens are there, right? Because you're trying to send it a sentence, which is like, what is the capital of France? Along with some things like, the words like user input, then the hook for the answer, and so on. So all of these are basically, tokenized, right? So I wouldn't say there's a one-on-one mapping, but there's a one-to-n mapping between the words and the tokens. So, and then for a model, the cost per API call tokens is also a factor, right? So that's how you could just find out, have an idea of what's the number of tokens that you're having. So we have set everything. Next, you just have to call the generate content method. So pass to it the prompt, the parameters which we set in the generation config, and of course, the safety settings. And once all of that is done, you get the response, and in this case, that is Paris. So what I'll do next is I'll just show this in a notebook. So again, in the interest of time, I'll kind of go through it a bit faster, and then okay. Yeah, so if you're using the Vertex AI SDK for Python, this is the package that you install, which is the Google Cloud AI platform. Once this package is installed, you need to restart the environment. Then comes the initialization that I was talking about. So if you look here, you see something called the demos Vertex, right? Which is my project inside my GCP environment, right? So you need to specify that. And you would also have something called a location, which would be something like US Central, US East, or whichever geography you are in. Once all of that is done, Vertex AI is initialized and ready to use. Good. And then the usual import packages. And then what happens is you can specify the models. So if you look at, I talked about Flash, and the latest model in Flash is Flash 002. You could either use it with the to suffix or just use it as Flash. And once that is done, as I said, you specify all the system instructions, set the model parameters, and you run this, right? So I told you about the tokens that it has. So it says that, these are the total tokens that go into the request, which includes the system instructions, which includes your question, which includes the hook that you put in for the answer. So altogether, total billable characters is 214, right? And this is the answer that you get. Again, you can print all the metadata, and then you also have the safety settings here, right? So what words were there? What was the severity score, right? Again, depending on that, your settings, certain things would be blocked in case you're trying to do that. Good, okay. So I'll come to the other one. Right. So, right. So when I was talking about the models, I told you that both Flash and Pro can handle not just text, but audio, video, images, and PDF as well. And we'll also be talking about the long context window here. So to give an example here, right? So what I'm doing here is I'm loading 2 images. So I'm taking it from the cloud storage, which you could kind of just take it as repositories where you could kind of store your unstructured data, right? Your PDF files, your images, videos, anything that you want. So I'm just loading them. And landmark 1 is what you see on the image at the top on the right side, and landmark 2 is what you see at the bottom one. Right. So next, again, the first line is to initialize the model with a generative model. And here, note that the difference is I'm not giving it any system instruction. Last time I told that, you are an expert in geography, you know the capitals and everything. Here, I'm not specifying anything. And then what I do is I call a generate content method. I give it the first image file, followed by a text like city is Rome and landmark is the Colosseum. And then what I give is an image file too. I run this, and the response that I get is what I've put it in red. So the model here is intelligent enough to understand that what I have given in the first two lines is specified an image and then given details of the city and the landmark. And then what Gemini is doing is taking the second image, analyzing it, and giving me the city name and the landmark name. So same thing you could do for audio. So I'll just show you the code. We may not have time to run it, but you could give it an audio clip and ask that to transcribe it, summarize it, and so on. Same with videos. Right. So next comes the context window. So context window is basically how much of data can you pass on to a model in one API call. So I think when these models started, we had a context window of around 2K tokens, right? From there, we grew to 4K, 32K, 16K, everything. And then with Gemini Pro, we have 2 million tokens, right? So what does this mean? What it means is that in one API call, you could give it 2 hours of video or 22 hours of audio or around 60K lines of code or a book or a documents which have close to 1.5 million words. So that's how you kind of translate it. Right. And most of you might have heard about RAG, right? So what it basically means is that there is only so much that LLMs know or that they have learned. But if you want them to answer certain questions, maybe from your enterprise documents or enterprise database or something, you need to kind of give it those documents, and so that it could kind of use that and learn from that. So compared to RAG, a question that comes up is, okay, now I have a 2 million context window. Do I really need a RAG, right? So the point to note here is it's basically a trade-off between your cost and performance. So this diagram is from a paper, which is like retrieval augmented generation or long context LLMs. This has been published by Google's DeepMind, right? So if you look at it performance-wise, long context wins over RAG, but cost-wise, RAG is like much cheaper. And this paper talks about a method called self-route, where they're using a combination of these two things to get best performance at a lower cost. Good. So So here, again, I was talking about the audio files. You could specify the path to an audio file, which is, again, sits in a GCS bucket. And something you could do is summarize it. And again, the most important part is the prompt that you use, right? Which says, please provide a summary for the audio, provide chapter titles, be concise and short, and all of these things, right? So this is the output that you get. Again, another interesting part is, can you transcribe this interview of this audio file? in the format of speaker, caption, and use speaker to identify these speakers and so on. Again, it does the same thing. So what I mean to say here is that it's kind of able to identify the various different people in that audio bit and then able to transcribe it as well. So thinking of scale, think that you could kind of do it around multiple audio files at one shot. Yeah. So again, this is another video. So let me. So this is again a video file. I'm just hurrying through it in the interest of time. And then what I'm trying to do is I say, provide a description of the window. It should also contain anything important which the people say in this video, right? And then it goes on to say that the video opens with an aerial shot of a train and so on and so forth. I'll come into the document analysis as well. But what you could also do is combine everything together. As in, you could give it a video, for example, this thing, give it an image, and then ask it to find at what is the time at which this particular image comes up in the video. So that's another thing where you're kind of combining the text in terms of your question, the image, and the video part as well. Okay. Going back to the presentation. Okay, next we come into the context caching and PDF processing. Right? So we talked about a 2 million context window, but every time you try to send in 2 million tokens, what happens is there's a cost associated with that. And suppose you have to analyze a video for multiple questions, right? There's one video and you're going to ask multiple questions on that. Or suppose you have a whole repository of documents, which is like 1.5 million words, and you're just giving it in the context and asking questions repeatedly, right? So in that case, what you could do is basically you could cache this whole context. And then in the calls that you have, just the questions would vary, right? Suppose it's like a document about maybe a storybook or something of that sort, right? So you might have questions about the plot, or you might have questions about the characters, and so on and so forth. So you just cache the whole thing and then do that. And in that case, again, the billing would be based on the cached content, the time for which it is stored, and so on and so forth. Again, another one that we have is PDF processing, right? Most of the documents are in PDF, and they have like, very, very varying structures. All you have to do is give that document to Gemini, and Gemini would be able to answer questions or summarize the data in that PDF. So again, let's see how we kind of do that. I'll kind of show you the code for this as well. But what you have to initially do is get all your the content, right? Either in a GCS bucket or in a file system, wherever you want that. And then what happens is it gets cached. And once the caching is done, you have to call a different method, which is like from cached content. Earlier, what we were using was generate content, right? So instead of that, the method that you call kind of varies. And then you specify that generate content when you ask the question. So that's how this works. And then it kind of gives you the required response. Right. Then again, the PDF processing. So I think I'll show you this one in the code. But again, the point to note here is how you can specify the PDF file, which is like part. From URI, you give the link to the PDF file, specify the type to be application PDF. Again, in the contents, which was earlier prompt, you give a prompt and a PDF file, and then you kind of generate content here. So if you kind of see that everywhere, it's kind of, you are using the generate content API call. But along with that, you are either giving some additional data or you're kind of using a cached content, specifying it in the model. Right. So I'll first show you the PDF. Right. So again, so this is a 77-page document which says which on 1.5. So this is loaded into a GCS bucket. And then I kind of do that. And what I say is that you are a professional summarization specialist, and then please summarize the given document. Good. Okay, so while, right. So a 77-page document, in a few seconds, you do have a summary of that. Okay, so next is the context caching. So again, we start at the same place. It's the same package. You install the Google Cloud AI platform. You do the required imports. You set the project. And right. And here what we are trying to do is we are taking two documents. The first one is around 90 pages. The other one is around 150 pages, right? And we are trying to and ask some questions about both of these documents. So it says that you're an expert researcher, and so look at these research papers and then respond to these questions, right? So again, a lot of things are very common here. So in the contents, you use the part from URI to load these two documents from the cloud. And again, this is something which is kind of, I would say, different from what you've seen until now. So you specify the model name, and then you kind of decide what are the things that you should cache. So one is the contents, which is like basically the contents of these two files. And along with that, we also do a caching of the system instructions, because you don't have to change it from one call to another, right? So it's like, it's the instruction for this whole analysis. So you could cache it as well. And the last one is what is the time for which you need to retain this in the cache. So this is again configurable, and typically here I have set it to 60 minutes. So once this is done, so this would take around a minute to run to cache for these two specific documents. And once you do that, you will get all of these variables, right? So you would have a name for this, which is again an ID, again the resource name, which is again a part of my project, the region that I am in, and along with the ID of those contents, right? Yes, again, the creation time, expiry time, all of those things. And once you have that, you specify the generative model, and then you specify the cache content. And then you do the generate content here, and then you get the response. So this is the first one. And the next time you want to kind of chat with these documents, you just have to give a prompt, which is like, how do the approaches of responsible AI development and mitigation, change, whatever that you want to do that, right? So it's basically only the prompt that goes in for every subsequent request. So here there are a couple of things, and once you are done with it, you could always delete the cache. Okay, so that let's get into the next section, right? Controlled generation and grounding, right? So what happens is typically a LLM call is never used in isolation, right? So there are always a lot of steps after that. So going back to my first example, like I want to know what is the capital of France and I want to know what is the currency of that. So maybe with that, the next step that I'm trying to do is find the exchange rate maybe between the French currency and the currency of some other country X. Right? So it's basically you need to use that information somewhere else. And when you're trying to do that programmatically, a big challenge is the consistency of the outputs, right? Because otherwise what happens is your code will break. Last time you said, okay, the answer I got is like, say, answer, and then the capital is something of the country, right? And if you don't get it in that format and you're trying to parse it, you will fail. So what I'm trying to do here is I'm doing all the imports, and the focus here is on the prompt. So what I'm saying is list a few cookie recipes, and the output must be in JSON. And I'm just giving it a couple of examples. So what could happen is that LLMs being non-deterministic, you may not always get the same answer, right? So you could always get something like, a markdown like that with JSON. There's a recipe name, there's the ingredients, and then there are so many instructions. But when you wrote the code, what you expected was like, the name of the recipes, and your downstream code is just processing that, right? So again, hallucinations, you'll have a lot of problems doing this. So that's where the control generation with Gemini happens. So what you could do is, if you remember the generation config that we have, where we specify the temperature, top P and everything, you have something called a response mime type, and then specify a JSON there, right? And then I'll come into the example and then show you how you kind of specify that. So once that is done, your output would be in the required format, right? So the next part is every LLM has this problem of hallucination, right? So I tried asking, okay, who is Laxmi? So as much as I would love to believe all of this, what is happening here, I have never climbed Mount Everest, or I don't think I would ever do that now. But yes, hallucinations are a reality. And how do you kind of solve them? So one is prompt engineering. So what you could do is in that request, you could, yeah. So in that request, you could, basically maybe in the system instruction, or you have 2 million tokens, right? So you could take everything that you know about me, put it in that, and then send it so that the LLM would know who I am and then answer, right? Otherwise, RAG, take my resume or maybe some other document about me, put it over there, send it to the LLM, and it would give that. Or worst case, fine tune an LLM with all details about me, and you would get an answer, right? So these are the typical ways in which you could solve this. But there is another way, which is what we call grounding. So what do you do? So if you go into the Vertex AI UI, you would see something like grounding, and then you just enable it. And here it's grounding with Google search. What happens over here is it basically does a search on Google, and whatever output it gets from there is passed on to the LLM to kind of come up with an answer, which looks much more realistic. And there's a blog which talks in detail about this. And I've just given the URL here. So if you're interested, you could kind of go and read that. So a simple example of how this happens. So here, what we are trying to do is that LLM doesn't know who I am. So it's kind of hallucinating, making up stuff. And what you could do is you could empower it with a tool, which is the Google search retrieval tool. So it will use that tool to go search and get information. And then that's why you kind of provide the prompt, provide the tool, which is like Google search retriever tool. And then you also kind of set the temperature to as low as possible to reduce the hallucination or reduce the variance in the answers, right? So all of this happens. And then the question is, when is the next solar eclipse? So it goes, finds the answer to be August 23rd. Okay, so we talked about RAG, we talked about grounding on Google search, right? But not, so you don't need to do a Google search every time. So if you look at the blue box on the left, you ask the LLM to write a Python program to generate some Fibonacci series or ask some other questions, then it doesn't need to do a Google search. It has enough knowledge, so it could answer it. At the same time, if you're asking some questions about, what's the weather today or something of that sort, then it needs a Google search to be done. And then in Gemini, we have something called a dynamic retrieval. So basically what happens is when you give a query or a question, right? So in this case, write a Python script. So what it happens does is it kind of evaluates that and comes up with a score and then decides if that score is above a threshold, then only it would kind of go and do a Google search. Suppose you kind of set the threshold to be 0, it will go and hit Google search for everything, right? But otherwise, how you could basically, setting that threshold, I would say, is dependent on your use case. Try it out. What is it that you need latest information for, and what is it that you don't, and that your documents can answer, or what the LLM can answer, and you can kind of set that. So it kind of allows you that control, and this kind of results in significant cost. Right. So again, the grounding on Gemini, this is what I kind of talked about. Suppose you are an enterprise, you have your data, you want to search that, you could always go in for the Vertex AI vector search solution, which is a managed RAG, but at the same time, you want to kind of look up the latest information. You could always bring in the grounding with Google search. And also it's like the third-party content, you want to kind of get data from some authoritative sources. Google is currently working with providers such as Moody's for these analysis. So in the interest of time, what I'll do is I'll just skip this demo and then get into the prompting tools, right? So what happens is we had the Palm 2 model earlier. So you have written your solution for your use case, you have made a prompt. Then as the models evolved, the prompt which worked on Palm 2, for example, may not have worked on the first one. So what you would have had to done is kind of, work on those prompts, redo them, which takes a lot of time. So instead of that, and this process might repeat as new models are developed and if their structure changes. So what Gemini does is it has a solution called Vertex AI Prompt Optimizer. So basically, you give it a system instruction, you give it some evaluation criteria, and then you give it some examples, right? Suppose it's supposed to do a Q&A is the use case. You kind of say that, like what I put in the first example, right? You are an expert in something, and then you kind of give some questions, answers, and then you also decide your evaluation metrics. So what happens behind the scenes is it kind of evaluates it across these models against the target model, and then gives you a prompt which kind of gives you a very high accuracy. So that's something that we have. So this doesn't cover the entire spectrum of the Vertex AI for GenAI. We do have batch generation, we do have function calling, fine-tuning, evaluation again is a topic on its own, right? And then so many other capabilities, right? So yes. So we started with the question, which aspects are most important to you while choosing an LLM API? And we said usability, performance, cost, flexibility. And then with Gemini, it's easy to use, best performance with the long context, efficiency, flexible, and customizable, right? So that's what we have. And all the code that I've presented here are from one of these code samples. So you could kind of take that, and of course, feel free to connect with me. And yes.
So we're going to prepare for our next talk, and unless anyone has a real quick question, we're going to move into questions in our networking demo section. But we would love for you to take a quick survey. We also have a Vertex AI free trial here that you can take a photo of as well. And I'll get you set up for our next speaker, Benazir. Thank you.
Sure. Let me just get them.
Yep. Yeah.
A couple of seconds.
Great. Thank you so much for your patience. We're excited for our next speaker, Benazir, who's going to speak about scaling Gen AI using open models.
Okay. Good evening, everyone. And thank you for being here. Thank you for spending the exciting election night with us, learning more about Vertex. Okay. My name is Benazir Fateh, and I am an AI/ML specialist at Google Cloud. I've been at Google Cloud for 4 years now. And as part of my role, I help some of Google Cloud's largest customers solution and architect AI/ML solutions using Google Cloud's products. And not just Google Clouds, Google Cloud, at Google, we embrace an open ecosystem. So it's open source, it's very often multi-cloud, but of course, the motivation is to help them use Google Cloud products more. So today, I will be talking about using or basically creating GenAI apps, and not just building them on your computer for a small pilot, but how could you scale them? What are the resources that are available on Google Cloud that can help you scale your GenAI apps? I'll be talking about Vertex AI Model Garden, which is an offering at Vertex that helps you make use of not just Google's models, but also open models. I'll be focusing a lot of time on Hugging Face and Vertex AI, the partnership that we have, the capabilities that Hugging Face provides along with Vertex. And then we'll see a demo of how to deploy a GenAI app. And it's a fun application that my colleague, Ivan Nardini, has put together. So we'll end up having some fun questions we'll end up asking some fun questions to Gemini. Great. So before we begin, maybe by a quick show of hands, how many of you have been using Vertex? Okay, great. All right. And how many of you have been using Hugging Face or any other? Okay, great. Okay, great. So we have a good mix. So the idea is, let's imagine that you want to create a generative AI app using an open model. Of course, as my colleague Laxmi talked about, we have foundation models available at Google, Vertex, which is Gemini. So you could build a lot of apps using Gemini. But for whatever reason, you want to use an open model and create a GenAI app. That's what we'll be focusing more on today in my talk. So generally how this is the general user workflow of when a developer wants to pick an open model from Hugging Face and then test it. You pick a model, you read the model card, read documentation to understand, is this model good enough? You look at benchmarks, evaluation data set, etc. You pick the model. If you need to, if you need to tune it, you'll prepare the data set. And if you don't need to do anything, you'll just take the model and deploy it. Where does it need to get deployed is the decisions, are the decisions that you need to make. If you need to tune or train, then you prepare the data set and do that. But what happens when you need to do it at scale? What happens when you need to do it for an enterprise application? And, we all know that it's one thing when we are developing an application just for fun, or, to show to our community or show to our friends. But it's a whole different ball game when we are developing an application for an enterprise. Lots of other considerations about, how will it scale? Will it be able to run? Will it be able to take load at critical times? Does it comply with, different regions, especially in the GenAI times? I have seen, working with enterprise customers, I've seen that different regions, US, EU, regions in Asia have different restrictions on different types of GenAI models being employed. So you need to take into account regionalization, compliance, all sorts of issues that you need to consider. So these are some challenges, like especially when you're working with open models. So I have seen, even with open models, I have seen enterprises, especially the InfoSec teams, departments and enterprises, being wary of them. How good is this model? Yes, it is open. Is it open weights model? Is it open source model? What are limitations with this model? What was this model trained on? Which data set? So tons of things that are needed for approval if you are picking out a model from just anywhere and using. Again, then once the time comes to deploy the model, you need to find out if there are recipes. And by recipes, I mean, are there optimized hardware? Like, what hardware should you choose for this open model? Has somebody out there in the community done some benchmarking on it? If not, maybe you need to do it. And that's not an easy job. It does require deep expertise in, not just running a model. Forget the other things like tuning the model or training the model. That's a whole different ballgame. Third, you need to gather the compute resources. Does the platform does it have enough compute resources in the region that you need? Do you need to make reservations, etc.? All this takes time and expertise. So what if there was a place where, you got verified open models, so that it's easier? That first step of getting an approval from your InfoSec department was easy because, hey, it has been verified by Hugging Face, it has been verified by Google Cloud, and only after that sort of verification does it land on Google, in Google Cloud Model Garden. And what if, in this ecosystem, we are seeing several developers who are not ML developers, who are not GenAI developers. They are, maybe they are app developers. They just need to use some model that's available. How can we make it very, very easy for a non-ML or non-GenAI developer to just pick a model from Hugging Face or from Vertex Model Garden and just run? Just pick a model, deploy it, so that you could start firing your inference requests. And lastly, scalable platform. And that's, of course, something that, all of these are things that Google Cloud provides. By scalable platform, what we mean is there's an array of different machine types with different accelerator types that are available to you to choose, so that you could deploy your model. And if you need to scale it, you could do that. Great. I think I already covered most of it. So yes, like what if, you can get easy access to open model? What if AI expertise is not a prerequisite? Like any developer, by the way, even ML developers may or may not have the expertise to grab a GenAI model or a LLM model and then deploy it. And this managed framework, like where the deployment, training, inference, tuning, different steps in this ML workflow, is it seamless? Like, is there a platform where you could do this all seamlessly? So we present to you Vertex AI. So Laxmi already talked about Vertex AI. I think I'll spend just a little bit more time on this. What you see on screen is our entire Vertex AI ecosystem. Starting from the bottom, everything is built on Google Cloud's infrastructure. Google Cloud has TPUs, which are Google Cloud's proprietary hardware. And then, of course, we have a strong partnership with NVIDIA. So we have a lot of different types of GPUs that are available on Google Cloud. On top of it is what is called as Vertex AI Model Garden. And we'll dive deeper into this. In Model Garden, we provide, at this point, over 150 plus models. These are a combination of both Google models, the Google Foundation models, and Google open models like Gemma. Then we have open models, all the models from Llama, and then a variety of models from Hugging Face. And then we have partner models. We have models from Anthropic, Mistral, Meta, etc. What you see on top of it is the Vertex AI model builder. This is a series of different offerings. This is Vertex training, Vertex prediction, evaluation service, model monitoring service, feature store. Everything that you need in an ML workflow is provided as part of the Vertex AI model builder. So you could train, tune, evaluate, deploy, monitor your models. And then there are several customizations. So we'll get into that. On top of it is something, what you see is Vertex AI Agent Builder. And with Agent Builder, what we have done is created customized applications. The ones that we have seen are very, very useful or very commonly used in enterprises, be it custom chatbot agents or conversational agents, all of these search agents. Laxmi talked about the chat with your documents. We have Vertex AI Search, which is part of Agent Builder, where you can, which is a turnkey solution for talking to your documents. On top of it, we have created some more customized agents and then more umbrella solutions like contact center AI, healthcare, etc. I won't get into any of those for today since you're more focused on a developer experience. So with Vertex AI Model Garden, you can build and use AI from a single access point, which is the Vertex AI Model Garden. And we'll look to see what that looks like just in a bit. So in Model Garden, there are variety of models. Of course, we have the Google foundational models, which is Gemini. We have Google's open models, which is all the flavors of Gemma. We have open source models. And then we also have partner models from Anthropic, Meta, Cohere, etc. And I forgot, it's not just, these models are multimodal, not just text to text, but there is text to image, embedding models, you name it. All types of large language models, which Google verifies are available as part of Vertex AI Model Garden. Maybe at this point, or actually, okay, we'll take a look at it in just a minute. So again, yes, proprietary. Okay, I think I already talked about this. Now, each model in Vertex AI Model Garden comes with a card, comes with a model card. And in the model card, we talk about the model. We talk about what are the use cases where this particular model can be best used for. We also provide information about how this model was trained, how if it is available from the parent model, how this model was trained, and any evaluation benchmarks that are available are also available on Model Garden. And then, of course, there are we will see quick in a short while how you can deploy this model. So several deployment options and also available resources. Like, with a variety of our models, we already have pre-created notebooks, and with one click you can open that notebook in a open that resource in a notebook or in a collab, and you can see how you can not just run that notebook and deploy that model, but also how you can make changes. The code is right there available to you. You can make changes. So there are two types of deployment. One is a self-service deployment. So given a model, you could use either GKE if you so choose, or there is an option to deploy on Vertex AI and on Vertex AI prediction service. You will upload this model and we'll see how it can be used for inference. So we'll upload the model and deploy it to an endpoint. Deploying it to an endpoint means attaching real physical compute resources behind the model so that it could be used, you could use it for inference. Also, very interestingly, we have model as a service. And with model as a service, what we have done is with some select partner customers, we have created the endpoint for you. So all you need to do is, and we'll see it, the REST endpoint is already created. So it's fully serverless. What you need to do is enable that endpoint, agree to the terms and conditions, but then you can use that API in your applications right away. That is model as a service. Model as a service is only available with select partner models, but with the large variety of models that you see and models from Hugging Point, self-service deployment, because we do understand that, and many of our customers, this is the most major use case that we see. Customers want to be able to configure how they deploy it, whether deploying it on Vertex or deploy it on GKE. Configure and on Vertex Prediction Service, you can configure auto scaling. Like if you need to scale your app to multiple regions, multiple users, how can you configure auto scaling in Vertex AI Prediction Service? Okay, great. Maybe let's. So to begin with, maybe let's look at, okay, how did I get here? So it's just console.cloud.google.com. Again, I'm showing this. There were people who were not yet familiar with Vertex. So that's why I'm just beginning from the very beginning. This is what the Google Cloud Console looks like. I go to Vertex and I go to Model Garden. But maybe a quick one at Vertex. What you'll see on your left-hand side is all the different offerings, be it notebooks, be it the Vertex AI Studio is the entire generative AI studio that Laxmi showed, where you can interact with Gemini API, extensions, agents, and then for the ML developer workflow, training, prediction, model registry, monitoring, we have vector search, and then open source integrations like Ray on Vertex are also shown here. For our use here today, we'll look at Model Garden. So when you go on Model Garden, this is what it looks like. And what you'll see is there is foundational models. There are all the featured partners, and then there are partner models. So I can click on Anthropic and I can see all the latest models that are available from Anthropic on Vertex AI Model Garden. I can see Google's, sorry, if I can also search. So maybe if I do this, like Gemma. Okay, so you can search for models. So when I search for Gemma, it shows me all the different variations of Gemma, including Gemma, Gemma 2, Code Gemma, and Pali Gemma. Sorry. Okay. So when I go to Meta, I see all the different Llama models. So let's first quickly start with the simpler option, which is if you wanted to use model as a service. So for model as a service, you will see it look like this. So this is Llama 3.1. When I do a deploy, sorry, not this. The Llama 3.1 API service. So when I click on this, by the way, there was an enable button and I've already enabled. I have already accepted the terms of use, etc. So the enable button doesn't show. But what I see is with this Llama 3.1, I already see the endpoint for all the different Llama models, and I could use them. I could create a prompt and actually fire the prompt to this Llama model. What I also wanted to show is there is overview, some information about the Llama, this particular Llama model, use cases, documentation, training data. This, of course, because Llama has been, or Meta has been very open and transparent with sharing their model information. But one more thing, open notebook. So there is a link to this open notebook, which shows all the different notebooks that we have pre-created for you. So if you were to click on the notebook, it opens a notebook in the Vertex AI notebook service, and it will show you the entire notebook. So this is complete with everything that you need to do to further fine tune it or deploy it, etc. Great. So other thing, so this was model as a service. The other thing let's get into is a self-service deployment. So with self-service deployment, it's the developers, the onus is on the developer to decide where they want to deploy this model. And there are two options. So let's go back to our and maybe this time let's select a Gemma model. Now, when I hit deploy, what you see on your right-hand side is the two deployment options. So you choose, be it Vertex AI or GKE. By the way, with some select Gemma models, we also have a third option. It's available in Dataflow. And there are some pre-created recipes available in Dataflow to do inference on some of the Gemma 2 models. So what do you see here with Vertex AI and GKE? The first step is to deploy the model. Now, under deploy, you will see a variety, like all the Gemma 2 models that are available. Let's pick a lightweight model. There is a model name, you can change it. There is the endpoint name, which is the name of the endpoint that you will be using in your API calls. And then there are deployment settings. To begin with, there are just region and what machine type. And Gemma 2, these recipes of Gemma 2 are available with the Hex LLM container, which is Google's TPU, which is a serving framework optimized on XLA and running on TPUs. So the machine spec is this. Now, these are what you see here with respect to machine spec. And if we were to, let's say, select a bigger model, a 27B model, you will see that so we have tested what would be the optimized hardware for any model and then presented that here. So you'll see the machine spec here. And yeah, well, I won't deploy this one, but let me see. If I deploy this smaller one, which is Gemma 2 2B, I select US West and I hit deploy. Now, what happens after you hit deploy? So let's go to model registry. And what you'll see in model registry is, so this one I deployed in US West. Oh. Okay. I think it was US West 1, but okay, 730. Okay, so this is the one that I just right now deployed. So once you deploy a model, the model resource becomes available in model registry. And then the next thing that you need to do is then deploy it to an endpoint. That process does take around 15 to 20 minutes. So I'll just let that happen. But once that model is deployed, you get the endpoint ID. We'll get into that later for the model which I've already deployed. But this is what it looks like. The model that you deployed ends up in model registry. Now, Vertex AI model registry is your central registry for all models. Whether you have imported a model from Model Garden, whether you imported a TensorFlow model some other way, TensorFlow, PyTorch, Scikit, whichever framework model, whether you created a model on BQML and you imported it on Vertex, or you created a model on Vertex AI training. So wherever you created a model, whichever way, if it's on Vertex, it shows up in model registry. Okay, so great. What we saw. So what we saw was the option for one-click deploy. And yes, there are options to do both Vertex AI and GKE, and there's documentation available for both. I don't have an example of deploying on GKE right now, but what I showed is the one-click deploy option for a Gemma 2 model on Vertex AI. Now, you might ask, where is this model running? So what we saw, like once the endpoint deployment finishes, this model, actually, let's go back here. Once this endpoint deployment will finish, you'll be able to fire inference requests to this model using that endpoint ID. This model is running in the Vertex AI prediction service. And if you need, you can also, if you need it to auto scale, you could provide extra resources and do auto scaling. And what is it using behind the scenes? Well, there are these available. So on Vertex AI, we have pre-created optimized containers for serving. So there is a variety of regular TensorFlow and PyTorch containers, but we also have VLLM containers, if you so choose, and Hex LLM containers. I think the choice to like select a container becomes more usable and more like needed if you're implementing this on GKE. But yes, we do have all these containers available if it was any model. And then yes, we will talk about the Hugging Face part. Great. So what happens when you're using a Hugging Face model? So Hugging Face and Google have a strong partnership. Such that models that are available on Hugging Face and the entire ecosystem are available also on Google Cloud. So Hugging Face has this strong and direct integration with the Vertex AI model builder as well as Vertex AI model garden. So let's see that in action. And the idea is this: how can we help customers and developers build and use AI from a single access point with any open model that you prefer and at scale? Now, with deep learning, with Hugging Face, there are several optimized deep learning containers. One, they are pre-installed. These are deep learning containers, so they are pre-installed with all the frameworks and libraries that you need. They are optimized to use GPUs and TPUs. Currently, like with on Hugging Face, the 4 types of deep learning containers: the text generation inference, text embedding inference, PyTorch training, and PyTorch serving. All these are available on Google Cloud. And you can deploy, looks like the latest. This is the one that I got the latest. It's 270,000 plus supported pre-trained models that are available on the Hugging Face. And of course, there's a huge support from the open source community should you run into any issues. Yeah, these are the 3 different types of families of the deep learning containers, depending on your use case that you'll need. The text generation inference is supported. Actually, all 3 are supported for depending on your use case. Now, what does the workflow look like if you are getting a model from Hugging Face? So first thing is you would deploy the model from Hugging Face. There are 2 ways to do that. You could go to Hugging Face website and do a deploy directly from there. We'll take a look at it maybe right now. So if you're on the Hugging Face Hugging Face hub and you've already selected a model. So in our case, for the app, I needed the Flex 1 dev. You will see a deploy button here and you'll see integration with Google Cloud. When I hit that, I'm directly taken to this page on the model garden where I've already selected the model from Hugging Face. I've hit deploy in Google Cloud. It directly takes me here where I can do a deployment on Vertex. So model name and also what is the optimized recipe for it? What is the optimized machine spec that you can use to deploy it? The other option, going back here, the other option to deploy a model from Hugging Face is, of course, going through Model Garden itself. So I think we saw here. So on Model Garden, you will see Hugging Face, and then you can search for a model. And this will show up the Hugging Face models which are available on Model Garden. And then again, when I click on it, I'm taken to the same option where I can change region, choose hardware if I need to, and then deploy. And then what happens next? So once you discover, once you deploy the model, you can also do other things like I mentioned, if you so need, tuning, evaluating, etc., or monitoring using the Vertex AI model builder. Okay, this is just going into a little bit more detail. I already showed how you can discover models from Hugging Face or discover those models from Vertex AI Model Garden. Great. So now let's take a look at a small application and about creating an app. This app is created by my colleague Ivan Nardini. I'm just here presenting it. But this is a very cool app. Basically, what this is doing is we'll submit a riddle to this app. This app is a combination of two models. One is a Flux model, which we have taken from Hugging Face. The Flux model is a 12 billion parameter model, and it does text to image generation. And then we'll use Gemini Flash. So what we'll do is we'll give a riddle to this app. Gemini will understand the riddle, find the answer to the riddle. The answer will then be given, given that answer that Gemini finds, it will generate a prompt, and then it will give that prompt to the Flux app, and the Flux app will convert that, that prompt from text to an image. Great. So let's see how to build it. So first we need this Flux model, which is an open source model. Now, Google also has text to image models, but today we are focusing on open source models. So we'll do Flux from Hugging Face. So step one, and we also have a notebook, but these are the main snippets from the notebook. First step is, so it's using the deep learning container that is needed for this model. And it's taking this model from Hugging Face and then deploying it on Google Cloud. As step two, it will, so we see the model resource. So by the way, this is the notebook. So in this notebook, I set up initial libraries, set up my project, location, etc., import libraries, and then I create, I assign what the deep learning container URI is, and I click on, I do this, this is basically uploading the Flux model from Hugging Face to Vertex AI Model Garden. And if we take a look at it, it shows up in model registry. I did this in Europe West 4. Okay, so Flux model. I did multiple invocations before, so that's why you see multiple, but this is the one that I did just now at 7:23. Now, what happens next is we deploy it to an endpoint. I won't do that because it does take 20-25 minutes. But what you see is you can add the required machine type, accelerator type, types of number of accelerators, etc. Well, finally, once the model was deployed, what I did is I took the endpoint name, endpoint ID. So it was deployed, and it was deployed to an endpoint, which means compute resources were attached behind that model resource. And now it's ready for me to do some inference on the endpoint ID. And now I can generate some predictions on this deployed Flux model, the model that we just downloaded from Hugging Face and I deployed earlier. But I can generate a response to it now. So now Flux model is doing text to image generation. So I just tested out with this, or I can change it to cat. Great. Okay. So great. This is one piece, which is text to image generation using Flux from Hugging Face. This whole thing is happening on Vertex AI using the Vertex AI prediction service. Okay, what next? So as part of our entire app, and I think I don't know if I'm over time, but okay, good. So what next? Now the next part is this other piece, which is Gemini Flash is also included here. Gemini Flash is the one which will understand what the answer to the riddle is and create a prompt. So I assign project ID, model ID, etc. The model ID, as you can see here, I added it to be Gemini. Yes, the latest version that we have, Gemini 1.5 Flash 2. And I initiate using Vertex AI SDK. I set up some generation config, some safety settings, etc. And then I call that model, giving it a prompt. I call this model. I give it some context, that you are the best riddle solver. This is the context that we are providing to Gemini so that it finds the answer for us. And then it will generate prompt. So given you are the prompt engineer, so Gemini is the prompt engineer because Gemini is supposed to find the answer and then as the next call, create a prompt to give to Flux to generate the image. So all that happens here, we give the generate image. This particular response that's coming from Gemini is given now to the Flux model to generate the image. Great. And finally, using the Gradio app, we launched the app. So I have already done that, and Gradio is running here. So, and I already started with a riddle, but let's see if there are some riddles from the audience. I would love to take those. Mainly, let's go around this workflow a little bit more. What's happening here is, this is the prompt that we gave. It was given first to Gemini here. Gemini generated an answer. So Gemini found the answer to the riddle. It said, what has legs but cannot walk is a table. It then made a second call to Gemini itself and said it created a prompt. The prompt is this. It created a prompt for table. And then this image prompt was now given to the Flux app that we got from Hugging Face, deployed and deployed on Vertex AI. And Flux generated this image of a table. Great. So yeah, if there, by the way, am I here? Let's see. Yeah, these slides are further going into, this is the flow of the app. So this is the entire workflow that I showed. Happy to take any riddles if you have one handy, and test Gemini and Flux. There is one? None? Okay, no problem. Otherwise, I had this website open to copy paste. Sure, I will. Maybe for this app, what will help is if it's like an image that we can generate. Like, I don't even know what the answer is. Okay. Broken. Okay, any guesses? Okay, let's see. Okay, good. Okay, and okay, great. So yeah, well, takeaways and finally, so what we saw is how you can grab a model from Hugging Face and use this amazing integration that we have between Hugging Face and Google Cloud and deploy a model on from Hugging Face on Google Cloud. Now, what happens when you need to scale? What we saw is on Vertex AI prediction service, and even when you're deploying the model, you can choose different resources. We do have some pre-filled optimized resources, but if you so choose, you can select different compute resources. Deep expertise. There are several pre-made notebooks and these recipes already created for you. You can build on top. You do not have to decide how to deploy a GenAI app, a GenAI model if you don't want to, because it's pre-made, pre-created for you, saving you lots of time. So at Hugging Face, with Hugging Face or Google Cloud integration, you can get access to several open models. And AI expertise isn't a prerequisite. Deployment and training flow seamlessly. We have configurable options. If you want to deploy it on GKE, we have seamless options with Vertex AI fully serverless or fully managed platform. All this so that you can focus on building AI applications. Great. With that, here is a link to some resources. Happy to, if you have any questions, I'll be hanging around here for a while. If I can answer any questions, or there are several of us from Google, if there are questions we can answer. And then, yes, a survey and a link to Vertex AI free trial. Great. All right, thank you.
Thank you so much. What a great demo. And we're excited again that you all stayed through both presentations from our great speakers here, Benazir and Laxmi. We do have a good team of experts that will be able to speak to you in our breakout demos in the back. So if you have more questions or want to learn more, please join us for the networking that is taking place after. We'd love to talk to you more about how to use open models, Gemini API, Vertex AI. We have some free trials as well. So come talk to us for a few minutes before you leave. We'd love to talk more. If you have any questions, let us know. Thank you for being here tonight.